In the name of Allah, the entirely merciful, the especially merciful, may peace, mercy, and blessings of Allah the Almighty be upon all of you. I am Umar bin Abid, and you're watching Umar Linguistics. So, dear viewers, as you know, in last lecture, we started some lectures on a course in phonetics, and we are going to look at phonetics in detail. So, in this lecture, we are going to discuss sound waves. And as you know, this channel is bilingual, so each video will be in English as well as in Urdu or Hindi. So if you want to watch this video in Urdu, so I have given the link in the description below, so you can watch this video in Urdu or Hindi too. What we are going to discuss today is how we can hear sound, or in other words, we are also going to look at pitch, loudness, and quality of a sound, waveform, and spectrogram. So it's going to be an important lecture. So in last lecture we discussed how sounds are made or how sounds are produced, and now we shall look at how we hear sounds. The way in which we hear sound depends upon its acoustic structure. So what does it mean, acoustic structure? That how our sound travel in air. So what kind of pressure it creates in the air when we produce a sound, and how when it reaches our sound, how what is the shape of that sound when it reaches to our ears, or we when we listen to a particular sound, so what is the shape of that sound which we are listening. So as in last lecture I discussed why we studied phonetics, so now we are going to study that why acoustics. So actually acoustic phonetics is another branch of phonetics. So there are a lot of reasons why we study acoustics. First of all, linguist and speech pathologist, who are speech pathologists, as I have described in last lecture as well. So they need to understand that how certain sounds become confused with one another. So you may have observed many people you are talking to, but they are listening something else. um, Sometimes they are confused between two different sounds. Sometimes they are unable to differentiate or distinct two different sounds. Sometimes these are the reasons of, sometimes the reason is that that we are not paying much heed to that person. But sometimes there may be some medical reasons. Sometimes there may be the reason that the person is highly aged, 70 to 75 years. So if this is a medical problem, so they, in that case we have to consult speech pathologist, and then they treat us in this way. They treat our ears in the way, so we are able to differentiate between two different sounds in which we were confused. So on the other hand, we can give better description of some sounds such as vowels by describing acoustic structure rather than by their articulatory structure or articulatory movements. So in while describing vowels at articulatory level, that how they are produced, we make a shape like this. But sometimes this shape or articulatory movement mean that how we are producing sounds, which is actually we study in articulatory phonetics, that in at which part of your mouth your tongue will touch and you will produce a certain sound. And how you produce a vowel like a, o, e, what is the shape of your tongue, what is the height of your tongue, what is the shape of your lips. So this is all we study in articulatory movements. But these articulatory movements are many times insufficient or are not as accurate as acoustic structures are. So therefore we also study acoustic structures or acoustic phonetics. Then a knowledge of acoustic phonetics is also helpful for understanding how computers synthesize speech. So there are a lot of can say AI software like Google, OK Google, Siri, and Cortana. So how these kind of robots understand our speech, how they synthesize, means how they combine those sounds, and how they understand that what we are saying. And sometimes you may have observed that these softwares are unable to understand what we are saying, because they are not actually humans. They only work on the data which they have. So how they synthesize, they have some type of data. So this is also where acoustic phonetics comes. Furthermore, as in last lecture, we watched an X-ray film of the phrase on top of his deck. So it is impossible actually to always look at the speaker, that what the speaker is saying, how his or her mouth is moving, how his or her articulators are moving. So it is not always possible to make X-ray film. It is not always possible that the speaker is in front of us. So um, uh, for example, now you are listening to me, you are not watching me, you are not watching my articulatory movements. But with spectral analysis, with if you record my speech, because this is the best way to do it, and analyze it acoustically, so you can even um, suggest my articulatory signatures, my acoustic signatures as well. And even you can suggest that how I am producing certain type of sounds. So this is the way, and this is the reason we also study acoustic phonetics. So in what way speech sounds differ? So speech sounds may differ in pitch, loudness, quality. We can also discuss here frequency, amplitude, and other ways as well. And actually these concepts, as we'll move further in incoming lectures, so we'll discuss these concepts in detail and in a more rigorous and in a more deep way. So for the time being, if I describe pitch, so actually pitch is the psychological impression of fundamental frequency. So what is the fundamental frequency? I'll show you in spectrogram what is the fundamental frequency. So in other ways, actually pitch is the psychological impression. For example, usually when vocal folds vibrate at high, you can say at high frequency, so at that time we perceive the pitch is high. On the other hand, when vocal folds uh, do not vibrate as high as they should be, or vibrate uh, you can say in a low frequency, at that time we perceive that the pitch is actually low pitch. So for example, when we listen to some songs, so or in other words, if I say what is your name, so here you perceive that I am saying that what is in a high pitch, in a high note. So this is actually perception. And actually normal people, we human beings can hear to 20 to 20,000 hertz. If you have ever observed, or if you have ever studied the frequency of other creatures as well, so you will come to know that we humans are at much, you can say, at much benefit having this frequency. If the sound is below 20 hertz, so actually it is we will be unable to hear that sound. But it is, if it is above 20,000 hertz, so it may disturb us sometimes. And another thing, about 30 to 35% people between 65 and 75 years of age, they lose some capacity of their hearing, of listening to higher pitch sounds, and this condition is called sometimes presbycusis. So for example, on the now two vowels may have same pitch, they may have same loudness, but they may differ in only that one is, for example, in bad and in bird. So in this way they may differ, they may have same pitch, they may have same loudness. These two vowels may have same pitch, may have same loudness, but they may differ in their, just like in their perception. uh, this is bad and this is bad. And similarly, two or more vowels may have the same pitch loudness, but they may have different quality. We can also define pitch as the perceptual correlate of the frequency. Perceptual correlate of frequency mean that these two are dependent. These two are dependent. The higher the frequency, the higher will be the pitch. The lower the frequency, the lower will be the pitch. Loudness. Loudness is perceptual correlate of the acoustic intensity. What is acoustic intensity? I'll also describe acoustic intensity through spectrogram as well. So acoustic intensity in simple words, if the sound has higher intensity, it will be heard as more loud. And usually when we describe loudness, so amplitude is a good criteria, is a good way to look at the loudness. The more the amplitude, probably the more sound, the more loud will be the sound. For example, if I say father, which we will look at later, father, so surely you are listening, if you listen it again and again, so you will perceive that a is more louder as compared to f or as compared to the. So once again, just like pitch, loudness is also a subjective measure. That is, it totally depends on the listeners. Interestingly, it is highly possible. It is highly possible that a person may not listen to some sound as loud as the other person perceives that sound loud. So um, two person may have different perceptions for the same sound. Some may say that it is too loud, some may say that it is not too loud. So actually it requires a lot of effort, it requires human listeners, and sometimes it's difficult to measure the loudness. If we talk about quality, so broadly speaking, the sum of the perceptual characteristics of a single speech sound. So what is the mean of sum of the perceptual characteristics? It means including pitch, including loudness, including frequency. Once again, quality is somehow a perceptual phenomena. Uh, so sum of the perceptual characteristics of a single speech sound, this is the quality of that sound. Now we are talking about variation in air pressure. So when we speak, air disturbs, and actually when we speak and we exhaled air from our lungs, so air vibrate. And just like when you throw a stone in a pond, and there will be ripples in the pond, so just like when we speak, the air vibrate just like that, and the air has disturbance just like that. And especially when these are voice sounds or vibrating sounds, where vocal folds are vibrating. So while producing sound, variation occurs in air, and these variations are due to speakers vocal organs. Vocal organs include our whole articulators and their mechanism, and how the air is coming out from mouth. So what does it mean that when you produce a, on the other hand when you produce oo, so both are creating variation in the air, but the variation in the air in both cases will be different. In the case of voice sound, the vibrating vocal folds chop up the air stream. So what happens in when we produce some voice sounds, so our vocal folds vibrate and they chop up the stream of lung air. What happens that they break the air into different pulses. Different pulses mean and different pulses of relatively high pressure alternate with moments of lower pressure. I am just going to show you a graph as well just after that. What is the mean of pulses of relatively high pressure alternate with moments of lower pressure. When we produce, so our vocal folds chop up the airstream and break it into different pulses of air, one of high pressure and the other of lower pressure. So a graph of sound waves is similar to a graph of movements of the eardrum. What we look at when we look at the sound graph, when we look at the sound wave, it is actually very similar how the eardrum uh, moves when a sound reaches to our ears. So now just look at a waveform and a spectrogram. So this is the waveform. So this figure has two parts, the upper and the lower part. But first we'll discuss the upper part. So actually this is the word father, which is actually pronounced by Peter Ledfogt himself. And you can say this the duration lasts for 0.6 seconds. Usually when we study a waveform, so at the x-axis, which is this, at the x-axis we look at the air pressure. On the other hand, at the y-axis, which is also known as abscissa, and the x-axis also known as ordinate. So in on y-axis we look at the time, but because it is not the complete graph, we'll look at it later. So here you can say that this whole word lasts for 0.6 seconds. We'll come to it later. Now if we look at this form, actually this is the waveform of a single vowel a, and here you can say you can see at the four major peaks, 1 2 3 4. So actually this shows that the vocal folds vibrate at uh, 0.01 second, means at every 0.01 second vocal folds are producing a pulse of air. So what is and why is that so? Because usually our vocal folds vibrate at 100 times. 100 times vocal fold vibrate 100 times per second. There are 100 vibrations per second. So because Peter Ledfogt is a male, and usually male have frequency of 120 to 200 hertz. On the other hand, female may have the frequency of 200 hertz to 400 hertz. So these are the four major peaks, and you can in these peaks you can also look at the alternate pulses of lower pressure and high pressure. So this is the way. Because these are just four vibrations, so it means in 1 second there will be 100 vibrations in complete 1 second, but it is 0.02 part, and on the other hand it is the 100th part of a second where one peak or one waveform is produced. So it shows what is the air pressure variation in these 0.04 seconds, or and how the changes in the peaks. As you can see, this is slightly high as compared to this one, and this is because, as I have described, this is due to the shape of the vocal tract, or on the other hand shape of the sound. So for example, if I say ooh, so ooh may have different waveform as compared to this one, but a on the other hand will have different shape of the waveform as compared to this one. Now if we once again come to the upper part, so it is the complete waveform of the word father, where this was only the waveform of the sound a. So the all variations are not visible in this waveform, because the time span is too short, and we have not zoomed it as much as we could. So let's move to a software which is Prat. Just to show you, so I have also pronounced this word father. Let me just pulses. All right. I have also pronounced this word father, and then I pronounce what is your name. So leave it. Just look at this. So you can see that my waveform is just like similar to Peter Lectro, because I also pronounce it like father. So if I zoom it now, I have increased the time span, so now you can look at all these variations, and these blue lines shows the pulses of air produced by vocal folds. So here in this word, these vertical lines are corresponding to individual pulse of air, which I have uh, shown you here, because I have zoom in this word, and here the pulses are actually highly visible. So you can download this software, and as we move on uh, in other videos, so we look at this software in detail as well, and I'll also inshallah make a separate video on detailed analysis of spectrogram as well. But it is just the beginning. In the incoming videos we are going to look at many spectrograms and will be used to it. So the pulse of air which are not actually highly visible in this waveform, we can look at the pulses 1 2 3, but actually these are more, because this is just too compressed. But here in this software part I have described that these are highly I have zoomed it out, so there is a lot of, you can say, space between these pulses. Next, if we look at this fur, so here in fur we have not high amplitude, or in other words, the variation in air pressure due to this sound is not as much as in the incoming vowel, and the reason is that, first of all, this is fricative, and on the other hand, and this is also not just fricative but voiceless fricative as well. So so it means the vocal folds are not vibrating, so therefore amplitude is very low, and therefore you will listen to this sound as quite you can say as quite silent, or in other words, you will not listen to it as loud as you listen to similar is the case with this and this one. But here once again we have another vowel, but because it's at the end, so once again we are not looking at high amplitude, but this part actually has high amplitude. Then if we talk about the acoustic intensity, as I have described you, so as I have talked earlier, so if you look at here, let me just, oh, sorry, if you look at here, so you can look at these black bands here, here, and actually this is the first black band. So actually this is what we call the fundamental frequency, because in vowels actually we have, for vowels or for many sound, we have more than two levels of frequency. So f1 is called the fundamental frequency, and this is actually the first, second and third, and even sometimes four. So now we are moving towards the spectrogram. This was the waveform analysis, and now we are going to look at the sound spectrogram. So in order to visualize what the ear hears, so we have to perform spectral analysis of sound. So in order to visualize what the ear hears, so what does it mean? So actually a spectrogram shows that what is the shape of the sound when we listen to it. What is the shape of the sound uh, when we listen to it, or in other words, what might be the shape, what might be the shape when it reaches to the ear, and how we perceive a sound, what is shape of that sound which we have perceived. This is spectrogram. On the other hand, what we have, just look at the waveform. So waveform shows the difference between noises and vowels in both amplitude and periodicity. This is the actually amplitude, and this is actually the periodicity. So we usually look at periodicity in vowels. Periodicity mean that a pulse of air repeats every time. Or in other words, a same waveform repeats. So this is one waveform, this is another, this is another, this is another. So waveforms are repeating, same waveforms are repeating at the time, again and again. This is periodicity. So this is the spectrogram. And in spectrogram, the analysis of the word shaw has been done, but not the complete, just a small area, or in other words, just a small window of sh, and just a small window, or in other words, just a small part of a has been analyzed. So these shaded areas are acoustic waveform, which this is the complete waveform of Shaw, and these shaded areas has been spectrally analyzed. This is the amplitude of both these small windows, and the darker the darker the line, the higher the sound, or in other words, the higher is the energy, the higher is the acoustic intensity. This is the frequency, and this is the amplitude. Now what they have done, they have rotated these slices, so it becomes a three-dimensional spectrogram. Now if you just look at here, you are looking at these darker spaces, darker slices 1, 2, 3 times in a, and only almost one time in sh. Now if you look at this sound here in Prat, let me, so here you are also looking at just a minute, dark bands 1, 2, 3, here 1, 2, 3, these are highly, you can say 1, 2, 3. So these are actually what we I was talking about. These are called formants. So we have 1, 2, 3, yes, 1, 2, 3 formants, these darker spaces, and there is a some space between these formants. So these are called formants, and each formant mean each frequency, f1, f2, f3, and f4, and so on. Similar is the case here, 1, 2, and 3 darker spaces, and this is the most uh, energized part, or you can say here the amplitude is the highest one. If we look at show, in show we don't have these darker bands here below, and the reason is that the consonants are not loud, are not voiced. Many consonants are not voiced, even this is not a voiced consonant. On the other hand, consonants have not usually such frequencies of f1, f2, and f3. For example, I say but how for how much time I can say shh, and this, even this shh at the end contain some sort of vowel. So this shows that sh has the frequency of almost 2800 hertz. On the other hand, has three frequencies. One is at almost 500, then at 13 to 1400, and then at just like Shaw 2800. So this is the spectral analysis, and this is actually the spectrogram and how to read it. Here in the x-axis or ordinate we have time, as you can see. On the other hand, in at y-axis or ordinate, abscissa, we have frequency. So this figure is composed of actually 213 spectral slices. These are 213 spectral slices with one new spectrum calculated every 2 milliseconds, and every 2 milliseconds we have calculated our new spectrum. So it means 0.2 seconds. So these are the spectrograms, and these are informative for visual display of speech sounds because they mimic the analysis performed by the ear. How ear listens, actually it is what we call spectrogram. So this is, and this is all about today's lecture, and these are the references: A Course in Phonetics, Phonetics for Dummies. Must download this book as well. Very easy and very detailed, and for some definitions you can download this book, A Dictionary of Phonetics and Phonology. It is also a good one book. So this is all about today's lecture, and in the next lecture we are going to look at places of articulatory gestures. So don't forget to give your feedback, remembering your prayers. Jazakallah khairan. Thank you.